Okay, hi everybody. Ready to do some math? I know you are. We're continuing in our notes, 5.1. We're on page 50, problem C. That's where we left off, so that's what we're doing. We're solving an equation, and the directions say we're going to do it in radians. Okay, no big deal. We can do this. All right, so the equation is sine x tan squared equals sine x. Now you remember from last time that we like to get our equation set equal to 0. So I'm going to move that sign over. And then, once I get everything moved over, I always check to see if there's a GCF. Well, there is. There's a sign. So out comes the sign. Now, what's left after I pull out the sign? Well, I'll have tangent squared minus 1. So I pulled out the sign, and I have tangent squared minus 1 left. So now I set them both equal to 0. So sine x equals 0, and tan squared minus 1 equals 0, which means tan squared equals 1, which means tangent is plus or minus 1, because I take the square root just like I do in a regular equation. Now, whenever you have a 0, we talked about this the other day, whenever you have a 0, you're going to be looking on your unit circle. You can't draw a triangle and do opposite over hypotenuse and all that. If it's a 0, can't do it. So we go around our unit circle, and somewhere on this unit circle, the sign is going to be 0. That's easy if you remember sign is y. So the sign is 0 here and here. In degrees, that would be 0 and 180, but in radians, it's 0 and pi. So there are the answers to this piece of the problem. Now, what about this piece? Well, first of all, clue in plus or minus. That means the tangent can be positive or negative. In other words, you're everywhere, you're anywhere. If the tangent opposite over adjacent is 1 over 1, you should recognize that angle there is a 45. But, I'll go ahead and write 45, but I'm in radians, so 45 is a fourth of 180, so it's pi over 4. So these little angles are all pi's over 4s. So my first answer is pi over 4. My second answer, though, is this one. You come around to your diagonal line there. That's the second one. This whole half circle is pi. So the red angle is pi minus pi over 4. Don't let the pi's confuse you. That's like 1 minus 1/4. What's 1 minus 1/4? 3 pi over 4, 3/4 pi. It isn't a whole pi because I didn't go this last little bit here. So it's pi minus pi over 4. Now what about this next one? What about this blue one here? Well, pay attention. That much is pi, and then I went an additional pi over 4. So that one is pi plus pi over 4, which is 1 plus a fourth, which is 5/4 pi. 1 and a fourth. And then finally, I gotta go all the way around to the next diagonal line. I go to the diagonal line. So all the way around is 2 pi, but I skipped this part. So it's 2 pi minus a fourth, which is 2 minus a fourth, which is 7/4. 8/4 minus 1/4. So this problem had a lot of answers. It has those two and these 4. Lots of answers. All right, there's one more in this section. All right, let's take a look at that one and see. Now, this one's a little different because I think most of the other ones that we've done, we have been able to factor something out. Like this one we just finished, we factored out a sine. Well, obviously, you're not doing that here. I know I could take a cosine out of these two, but I can't take a cosine out of that. And if you're going to take out a GCF, it's coming out of everything. So there's no GCF here. Instead, you need to recognize that this is a quadratic equation. This factors into 2 parentheses. Now, you all learned how to factor in first year algebra. This is just the same exact thing on a little bit bigger scale. So in the front of my parentheses, I'm going to put 2 cosine and 2 cosine. Because when I FOIL and take this times this, I will get 4 cosine squared. Now, at the end, I have to put 1 and 1, because, again, when I FOIL, 1 times 1 is 1. That's a negative, so these have to be negatives, so that when I multiply a negative times a negative, I'll get a positive. And look what happens when I FOIL. Look, please don't let yourselves be confused. It's a FOIL. So 4 cosine squared minus 2 cosine minus 2 cosine plus 1. There it is. That's factored. So now I set each one of those equal to 0. So 2 cosine minus 1 equals 0. So 2 cosine equals 1 and cosine equals 1/2. The good news is, won't that one be the same thing? So I don't have to solve them both. They're exactly the same thing. Whatever answers I get are going to be the answers. So where is the cosine? 1/2. Cosine is 1/2. Well, it's positive in quadrant 1 and 4. How do I know that? I remember that cosine is associated with x, and x is positive on the right side of the coordinate plane. Adjacent over hypotenuse has to be 1/2 cosine. I'm doing this without a calculator, so that's got to be special. This guy is a 60-degree angle. But I'm in radians, so instead of saying 60, I'll say pi over 3. Because 60 is 1/3 of 180. Now, one of my answers is pi over 3. In the first quadrant, it is pi over 3. My other answer, I gotta go all the way around. If I were in degrees, I would say 360 minus 60. So that red angle would be 300. But I'm in radians. So instead of saying 360 minus 60, I'm going to say 2 pi minus pi over 3. That's 2 minus a third. Well, 6/3 minus 1/3 is 5/3. So our other answer, our red answer, is 5 pi over 3. Not every one of these problems, these equations, is going to be solvable without a calculator. We are going to need our calculator to do some of these problems. So let's get our calculators out. Now the first problem there, number 5, the directions say answer in both degrees and radians. So we got to do both. It's not going to be that much extra work to do both. And I have the hiccups, of course. So let's just do it in degrees first. We just have to start with something, so we'll start with degrees. And it says, solve cosine x equals 0.37. And I'm going to do it in degrees first. Now, I'm going to use my calculator, but there are parts of this that are very, very similar to what we do without a calculator. So first of all, where is the cosine a positive number? Well, I just talked about that. Cosine is positive in quadrant 1 and 4. Because cosine is associated with x, and x is positive on that side. Now, 0.37 is not special, so I'm going to go to my calculator. I'm going to make sure it's set in degrees, since that's what I said we do first. And then I'm simply going to second cosine 0.37. So this is the button I'm pressing on my calculator. I'm second cosining 0.37 to find the angle. And the angle is 68.3. I'll just round it off to the nearest 10. Okay? So 68.3. So the two answers to the problem are 68.3 and then the blue one, which would be, remember this is also 68.3, so the blue one will be 360 minus 68.3, or 291.7. Now, we need to talk about something, because we're not quite done with this degree thing. We're going to do radians in a minute, but that's not, we're going to do hardly anything any different. But we're not quite done with this. If you recall, these last problems that we did, the ones with no calculator, they all had directions like this or like this. And what that meant was, I was to find all of the answers in one revolution, 0 to 2 pi, one time around. So if I were only finding the answers in one revolution, then I'd be done. But notice that problem 5 does not give that direction. Number 5 says, find them all. Well, guys, there are infinitely many answers to this problem. because I want you to think about something for a minute. This black angle right here, let me get the blue one out for a second. This black angle right here, 68.3, if that's an answer, wouldn't this also be an answer? Wouldn't 360 plus 68.3 be an answer? Yeah. In fact, all of the coterminal angles for these two are answers to the question. So it's not just the first two we come to. It's all of them as we spin around, 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 both directions. So do you remember how we find coterminal angles? I hope so. It was a test question. How do we find coterminal angles? We add or subtract 360. So we're going to take both of these answers and we're going to add and subtract multiples of 360, because you can add more than one 360. You can add 360 and then another 360 and another 360. So we're adding multiples. So one 360, two 360s, three 360s, and so on. We're adding multiples of 360. So we're letting n be some whole number, 0, 1, 2, 3, da, da, da. And we are adding revolutions. So the first two angles, the ones we got from the picture, and then all their coterminals. And this is how we express coterminal angles. Plus or minus 360n. Plus or minus revolutions. 1 revolution, 2 revolutions, and so on. That's all of the angles in degrees. Now, if we're doing it in radians, the only thing that changes is I'm going to go to my calculator and I'm going to second cosine 0.37, but I'm going to do it in radians. So I'm going to change my mode to radians, and I'm going to second cosine 0.37. Now the angle is 1.19. It's in the same place. It's the same angle, just a different name. So one of my angles is 1.19. And then the other one, when I did it before, I did 360 minus 68. Well, now I won't do 360 minus 1.19. I'll do 2 pi minus 1.19. On my calculator, 2 pi minus 1.19, 5.09. Just like you did 360 minus, now you're doing 2 pi minus. Okay, but like before, we need all of them, not just the one time around. We need them all. So we're going to add and subtract revolutions. Now, in degrees, that was 360n. In radians, it will be 2 pi n, where n is some whole number. This means n is an element of the set of whole numbers. N is a whole number. This is how I found it. But here are the actual answers in radians. All right, hopefully your mind's not totally blown, because we got another one to do. Same directions, we're going to do it in degrees and radians. So here we go. Tan x equals 5. All right, so the first thing I want you to do is figure out where the tangent is positive. That's a positive 5. Where is it positive? Well, it's positive in quadrant 1, obviously. And I hope, you're saying 3. Because in quadrant 3, opposite and adjacent would both be negative. So when you made the fraction, it would be positive. I'm in radians, so I'm going to do radians first this time. So second tangent 5. That's how I find x. X is second tangent 5. The only way to get x by itself, the only way to separate those, in other words, is to second. So second tangent 5 is 1.37. So what are my answers? Well, this one is 1.37. What's the red one going to be? Okay, we've talked about this. The red one is going to be pi plus 1.37. Halfway around is pi plus another 1.37. 4.51. Now, those are the answers in the first revolution. But again, this question said find them all. So we're going to add and subtract revolutions, which in radians is 2 pi's. So we're going to add and subtract multiples of 2 pi. 2 pi n, multiples of 2 pi. And that's going to give me, I don't know if the video picks this up or not, that's 4.51. That's going to give me all of the angles, every possible answer to this question right here, in radians. Now I'm going to turn around and do it in degrees. It's going to be in the same place, but I'm going to set my calculator in degrees now. And second tangent 5, 78.7. Typed in exactly the same thing. I'm just setting degrees now, so my answer came out in degrees. Remember, whenever you type second tangent or second sine or second cosine, the answer is an angle. If you're in degrees, it's a degree angle. If you're in radians, it's a radian angle. So what are my answers? Well, one answer would be 78.7. And then what would the other one be over here in quadrant 3? It would be 180 plus 78.7, 258.7, 180 plus 78. One more time. If we had directions from 0 to 2 pi or 0 to 360, I'd be done. But because I need all of the angles, I need the coterminals. And in degrees, I get the coterminals by adding and subtracting multiples of 360. And we express that by adding and subtracting 360n, where n is a whole number. That's how we tell our reader that we're finding all of the coterminal angles. Okay, that's it for 5.1. Please keep an eye on Schoology and Power School for when that homework is due. We are going to go ahead and begin 5.2 now. And 5.2 is a totally different animal. 5.2 is proving in trigonometry. So in geometry, you did geometric proofs, remember your statements and reasons and all that. We're going to do proofs now, trigonometric proofs. And it's a little bit different. Sometimes it's a little bit hard when you first start, but you'll get the hang of it, I promise. And hopefully you'll enjoy it as much as I do. All right, I do need you though to have your colored sheet with you during this experience. Please have this right there next to you. And as last time, we're going to focus our energies on your colored sheet on the first 8, right here in the first column. You have a grouping of 5 and a grouping of 3. Those 8 are where our energy is going to be focused. I want to remind you that for the Pythagorean identities, I talked about this, but some of you were so out of it that I'm not sure you did as I asked, and that is that identity can be written in different forms. So that identity is on your paper. They're thetas instead of x's, but that doesn't matter. Next to that identity, put the other forms. So sine squared equals 1 minus cosine squared. And cosine squared equals 1 minus sine squared. Write those other forms down because you're going to need to know them. You're going to need to recognize them. And if they're written down, it's going to be easier for you to recognize. And then the same thing with this one. 1 plus cotangent squared is cosecant squared. So 1 equals cosecant squared minus cotangent squared. Or cotangent squared equals cosecant squared minus 1. These are not magical or mystical. I'm just rearranging the numbers in the equation. So if I subtract cotangent squared, this is what I get. If I subtract 1 from the original, this is what I get. So write these down. Have those written down next to the original. Same thing here. 1 plus tangent squared is secant squared. So 1 equals secant squared minus tangent squared. Or tangent squared equals secant squared minus 1. On the paper, those are 3 identities. All I have done is taken the same 3 identities and written them in different orders because they often show up in different orders. That should be written on your paper. When we verify an identity, verify, prove. The word verify, show that it's true, prove it. When we prove a trigonometric statement, we call this an identity. When we prove that it is indeed an identity, we manipulate one side of the equation until it becomes the other side. So in other words, we don't cross multiply, we don't do that at all. What we do is manipulate one side until it becomes the other side. So throughout the whole problem, this isn't changing. This is going to say sine x. Every step of the problem, this is going to say sine x. This isn't changing. I'm going to manipulate this using the things on my sheet and my own brain. Okay. So take a look at your sheet. Tell me what you see in that numerator. What do you see in the numerator of that problem? I hope you see a 1, because sine squared plus cosine squared is 1. Right there it is. So that's 1 over cosecant. Well, wait a minute. On my paper, it says that cosecant is the reciprocal of the sine. Cosecant is 1 over the sine. So what is 1 over the cosecant? It's the sine. So do you see what happened, guys? I manipulated this and it became the sine. The sine and the cosecant are reciprocals of each other. To be a reciprocal means you're 1 over the other one. So if you are 1 over the cosecant, you are the sine. If you are 1 over the sine, you are the cosecant. Don't be confused by that. Write that down if you need to. 1 over cosecant is the sine. Done. You just did your first identity and you did a great job with it. All right, let's try the next one. All right, so the next one says tangent over secant equals sine. Now let's talk about this for a second. What's tangent? Look on your paper. What's tangent? It's sine over cosine. Over, what's secant? 1 over cosine. Now some of you are capable of simplifying that, just boom. And some of you are going to need to think about this as sine over cosine divided by 1 over cosine. That's what this means. It means sine over cosine divided by 1 over cosine, which is sine over cosine times cosine over 1. Oh my gosh, what happens? The cosines cancel, and it ends up just equaling the sine. In general, kids, when you have a complex fraction, that's what we call this, a little fraction over another little fraction, making a big fraction. When the denominators match, they cancel out every time. So it's okay. You don't have to show all this. That's kind of the work behind the scenes. If you understand it, if you get it, you can just cancel those out. If they're both in the denominator. Don't be canceling them if one's on top and one's on the bottom. But as long as they're both in the denominator, you can cancel. And you just did your second identity, your second proof. You simplified this into sine. This isn't so bad. Oh my, look at this next one. It's big. We're not afraid. We are not afraid. So we have cosine, tan plus sine cotan equals sine plus cosine squared. So again, your job is to probably simplify all that into this. So we want to eventually end up with all of this becoming that. So how about if we distribute first? Does it sort of make sense to you seeing a cosine outside this parentheses that maybe distributing would be good? So we'll have cosine times tangent plus cosine times sine times cotangent. So all I did, cosine times this, cosine times that. Now let's do what we did over here. Tangent is sine over cosine. and cosine is cosine, sine is sine, but cotangent is cosine over sine. So in other words, I left my cosines and sines alone, but I changed tangent into sine over cosine, and I changed cotangent into cosine over sine. What do you think about that? Well, when you multiply these two, don't these cancel? This is cosine over 1. Don't those cancel? And that leaves you a sine. And here, these cancel. And that leaves you with cosine squared. And oh my gosh, isn't that what I wanted? That's what I wanted it to equal. Woo. All right, let's try the next one. Here we go. All right, what have we got? We've got tangent plus secant equals cosine over 1 minus sine. All right, well, we've only done a couple of these, but are you starting to get the idea about maybe what you should do to get started? How about if we change the tangent into sine over cosine, and we'll change the secant into 1 over cosine. I'm not making this up, kids. Look at your colored sheet. Look at your colored sheet. Now, the good news is I can add these together because they have the same denominator. The bad news is they don't match. I'm not done. And for the first time, I'm going to have to do something a little bit tricky. Okay? Here's what I'm going to do. This is what I have, and this is what I want. Now remember, you can't cross multiply, you can't touch this. This is just staying the same. This is getting changed. So when I look at what I want to end up with, I want to end up with a cosine on the top. Right now, this is what I have on the top. But that's what I want on the top. So because of the wonders of mathematics, I'm just going to put what I want up there. Mrs. Ford, is that legal? Yes, as long as I put 1 in the bottom too. Because I am allowed to multiply the top and the bottom of a fraction by the same thing. And I've chosen to multiply by cosine simply because I need a cosine up there. But Mrs. Ford, there's other stuff. I know, but I gotta have a cosine. So I'm gonna multiply top and bottom by cosine. Now, on the top, I have cosine, sine plus 1. And on the bottom, I have cosine squared. Now, I am getting very, very excited because on my sheet, my colored sheet, I ask you to write down, what does cosine squared equal? What does cosine squared equal? Cosine squared is 1 minus sine squared. So I'm changing that denominator into 1 minus sine squared because that's what cosine squared is, according to the Trig Bible. This, my friends, in the denominator here, is the difference of squares. I didn't do anything to the numerator, I'm just like bringing it along. But the denominator is 1 minus sign, 1 plus sign. It's the difference of squares. Just like x squared minus 9 is x plus 3, x minus 3. This is exactly the same thing. It's a square minus a square. Are you getting excited? Look, those are the same. Those cancel out. And what am I left with? And what did I want to be left with? Cosine over 1 minus sine. So that one was a little bit on the tricky side, but we made it. You just proved that identity. All right, that's enough, excuse me, for today. So good work. Remember to check to see when the 5-1 homework's due. I'll post that after I get all my days figured out. And I'll see you soon, hopefully. Have a great day. Bye.